Good morning, good afternoon, and good evening, everyone. I am Stella Kafka, the Executive Director and CEO of the AAVSO. And this presentation is on behalf of Sarah Beck and the AAVSO data validation team on an issue that is at the core of our services and a matter of credibility of the AAVSO science. Data validation is one of the critical functions of the AAVSO headquarters. Identifying and correcting data discrepancies require a good understanding of the stellar system at hand, attention to detail, cooperation between headquarters and observers, and extensive detective work. Our long experience at the AAVSO has showcased that data discrepancies are not necessarily related to a lack of the observer's experience or the instruments they're using to acquire data. Through the recent case of BT-MON, today I will discuss an example of our data validation process at the AAVSO and end with some of the most common reasons for discrepant data. So let me start with some background. BT-MON is a cataclysmic variable. This translates to being a semi-detached binary star system consisting of a 1.04 solar mass white dwarf primary star, which is accreting material from its 0.87 solar mass main sequence companion. The orbit has a period of about 8 hours and an inclination of 88.2 degrees to the line of sight of the Earth, resulting in an eclipsing binary with eclipses of 2.7 magnitudes in depth. Because of the deep eclipse and good photometric ephemeris was derived early on by Robinson et al. In 1982. Now, BT-MON is also a known nova. It was observed to erupt in 1939 and was discovered on a spectral plate by Fred Whipple. This is a known early BT-MON light curve here, presented in a catalog of 93 nova light curves published in 2010 by Richard Stroop and friends. And BT-MON is believed to have reached 4.5 magnitude at peak, which would have made it visible to the naked eye, but this value is an extrapolation. The nova was not observed at peak brightness, or at least it was not recorded at peak brightness. The brightness decreased after the outburst by 3 magnitudes in 182 days. This makes it a slow nova. Now, the light curve for the eruption had a long plateau, as it's demonstrated here. The nature of the system is still under debate. Although variations of the shape of the eclipse implied that the accretion disk size was changing from night to night, Williams in 1989, combining observations and models of the spectral lines in BT-MON, proposed that during eclipse, the line profiles are due to a spiraling inflow of gas in a rotating accretion column, suggesting that the system is an intermediate polar. What that means is that the accretion disk is being disrupted by the magnetosphere of the white dwarf, and accretion to the white dwarf is taking place through magnetic field lines. To our point, earlier this year, we received correspondence by Dr. Michael Shara, who wanted to use the BT-MON data for one of his projects. His primary goal was to study eclipse timing variations and discuss the hibernation model in CVs. Looking at the existing AAVSO BT-MON data through our light curve generator, he noticed something peculiar in the long-term light curve of the star. The filter light curves of BT-MON over the past 18 years are displayed here. The peak brightness over most of these past 18 years is around 15 to 15.3 magnitude. But after a certain date here, BT-MON occasionally gets 0.5 to 0.7 magnitude brighter, apparently reaching magnitude of 14.5 or even higher, brighter. Now, there are two possibilities. Either something changed in the system intrinsically, which is really exciting, or there's something going wrong with the data. So the PI asked the headquarters to check. Now, in as much as we would really love to believe that the changes in brightness is real, looking at the light curves much closer, we noticed that different observers were consistently reporting different values. Highlighted here, I present different observers' data. You can tell that observer 222, for example, their value is much lower than observer 444. And these are some of our most productive and experienced observers. Furthermore, To begin the search for the cause, we took a look at the phase plot for BT-MON using V-star. What we found is that the minimum is at the same point. All the data converge here. So it seems that at first look, the system does not have any eclipse timing variations. So the current ephemeris works really well. However, the depth of the eclipse, it seems to be diluted, like its field. Did it change? Also, the out of eclipse light curve has a scatter. Is that scatter real? We know that there is some known out of eclipse variations, but is this amplitude real? A little more detective work revealed that looking at the VSP chart here, there is a close 15.35 magnitude star, only 8 arc seconds to the north of the target star. So could this have contaminated measurements? This is a zoom in of an image of BT-MON, which is actually quite impressive. If you look very carefully, you can see the nova shell, which is the remnant from the nova eruption. You can also see a second star, this companion to the lower right, which is an unassociated star. It's either in the foreground or the background of the old nova. And actually, it's only less than 5 seconds apart, 5 arc seconds apart from the BT-MON shell. Now, in the finding chart, just zooming in, this, the circle, is BT-MON. That tiny little star here is not BT-MON. It's the companion that we discussed. Now, at this point, we wrote to each of the observers with the bright values in the light curve to check for contamination from the nearby star. Take a look at their aperture they used and whether this companion star was included. And in each case, the observers admitted that the companion was included in the aperture they used to measure the brightness of BT-MON, and they reprocessed and resubmitted their observations. So it turns out that when people performed aperture photometry, depending on how well their aperture was centered on BT-MON and how large it was, the unassociated star was or was not included in the aperture, causing variations in the out of eclipse and the in eclipse depth. For example, if the radius of the aperture was only 10 arc seconds, sometimes translating to just 2 or 3 pixels of your detector, you would include the other star in your photometric values, especially if it was a little bit off-centered. Did it work? When observers resubmitted their observations, we checked again on VPHOT and found the phase light curve was more consistent with the known behavior of BT-MON. Here's the before, and here's the after. So you can actually see that the depth of the eclipse is much more pronounced, much well defined. The scatter outside has a smaller amplitude, and this is actually the known amplitude from older reports and older papers of BT-MON. Now, this is also reflected on the light curve of the star. You see that the maximum here is more or less the same and very consistent between all observers. The question is, could this have been prevented? In cases like this, the AVSO chart provides all the information you might need. Just a closer look at the chart that tells you that there is a close companion, and a note in your observer's log under this name could have alerted the observers for a close companion. Also, after submitting data, just a quick look on the light curve generator points out to discrepancies in the light curve shape, which should be a red flag for observers. So, lesson learned. At the AVSO, we'll provide all the information necessary and relevant tools to check your data for quality. We would really, really appreciate it if you do so, because not all researchers will notify us when they see something unusual in the light curve, and it would be really embarrassing if discrepant data are being published and they are included in the system's interpretation of light curves. Now, this is only one case of data discrepancies. There are other reasons why data can be discrepant, and I'm including them here for completeness. For CCD observations, some common reasons that lead to discrepant data are saturation that result in a flat light curve. This can be rectified by checking your images and adjusting your exposure time. Close companions, like in the BT-MON case, please check your VSP maps and put a note in your reduction spreadsheet. There's just a small cases of stars like that, but they do matter. Also, reporting incorrect filters, low signal to noise, typographical error in the name of the target star in a report, entering a wrong or obsolete magnitude for a comp star into the software, reprocessing, resubmitting data without first removing the older version, so that leads to duplicate data, misidentification of the variable star, misidentification of one of the comp stars. All these things can happen, but they can't be rectified just by taking a look at your light curve in Light Curve Generator. Look at your data against other observers' data. Are there disagreements? Do they make sense? And please bring any discrepancies you notice to our attention. We're trying to check as many light curves as we can, but some cases escape our attention. And sometimes there is reporting of the wrong time and date, so please make sure that your clock is synced against the standard. For completeness, some of the most common mistakes that lead to discrepant data for other types of observing: DSLR, same as CCD, and not accounting for extinction in a wide field with high air mass. When you're looking low at the horizon, you have a changing air mass across the field of view that needs to be taken into account when you're doing your reductions. For visual observing, misidentification of the variable, misidentification of the comp stars, some typographical errors in the report, error computing the date and converting it to JD, trying to observe between below the telescope or binocular limit, meaning trying to observe really faint targets for too faint for your gear, observing with hard to see cirrus clouds. All those things need to be taken into account when you are taking your observations, when you're reporting them. You know, I've mentioned many times how the AVSO observations, your observations, are essential for science. This comes with a great responsibility to produce the best data we can. So please, please do check your light curves before and after you submit them. We would love to advertise to our professional astronomical colleagues that the AVSO's observers' data are reliable as they are. They can just go and download the data from the databases and do the research. And this way, we will increase the inclusion of your data and your names in scientific publications. In order to do that, we need your help and your cooperation. Truly, after all the work you put into taking and reducing your data, just taking one extra small step to check your data makes all the difference. With that, I would like to thank you for your attention to this matter. I'm looking forward to our live discussion and wish you clear skies and be safe. Thank you.